Well, it's great to see you here in class again. We're getting close to being halfway through week one. Right now, you should start to have a feel for what it's like to program in Python. You know about expressions, you know about variables, you know about functions. But really, the number of operations that you have at your disposal when building a Python program is fairly limited. So what I'm going to do in this lecture is I'm going to tell you about a few more operations that you have at your disposal to help build more interesting programs. In particular, I'm going to talk about remainders and modular arithmetic. I'll talk a little bit about how to work with strings and numbers, and then I'll finish it off by telling you how to get access to some more built-in functions inside Python. Okay, let's go to it. So let's talk about a few more operations that we can use in Python. For the first part of the lecture, we're going to talk about modular arithmetic. Now, you may not have heard that phrase before, but you actually know how to do modular arithmetic. In third grade, you learned how to do long division. You had a dividend and a divisor, and you divided one into the other. What came out was a quotient and a remainder. So that remainder is actually, essentially, you're computing modular arithmetic when you compute remainders. So I'm going to give you a few examples illustrating how to use modular arithmetic. So let's start off with a really simple problem. Let's say we have a two-digit number, and we'd like to compute its tens digit and its ones digit. So how can we get the tens digit? I think it's not too hard. We actually have something that computes the quotient. It's the integer division operator, //. So we could say num integer divided by 10. So 10 goes into 49 4 times. So I'm going to predict we're going to get out the number 4. Sure enough. Now we'd like to also get the ones digit. So how can we do that? Well, we need to compute the remainder whenever we take num. We take the remainder with respect to 10. So let's see if we can find out what the remainder operation is in Python. Let's go to Code Sculptor Python, and we're going to squeeze down here. Let's see, integers and floating point numbers. Let's scroll down. Modular arithmetic, that sounds kind of plausible. And sure enough, that's actually what we're going to use. We're going to use the percent operator to compute a remainder here. So we could say %10, and now we could print out the ones digit also, and we get 4 and a 9. And notice we can always reconstruct the original number by just taking 10 times the tens digit plus the ones digit. So there's nothing special about 49 here. That actually works no matter what. All right, let's talk about another example of modular arithmetic using remainder. So this is the classical example that you'll see. It's called clock arithmetic. And the idea is we're going to want to do computations involving hours and either a 12-hour or 24-hour clock. So let's pop over to OneNote here. And what you can see right here is I have kind of two tables. The one on the left here is the 12-hour clock. And so we list all the hours in the day on the 12-hour clock. We have 12 hours that are AM, 12 hours in PM. Notice that the hours start at 12, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If we'd like to do arithmetic on the 12-hour clock, we can almost use remainder to do that. So let's go down here and consider a problem. Right now on this clock, I have it listing the time as listed as 8 p.m. So here it is, 8 p.m. And I would like to skip and figure out kind of 8 hours ahead what the new time would be. So let's go down here and we'll just draw 8 hours, and I'll draw it very carefully. My handwriting's not so great, so I'll try to go slow here. So we go ahead. We end up here, and where do we end up? We end up at 4 a.m. And what do we do up here? We went plus 8 hours. So we could do that using remainder. We could take 8 plus 8 would be 16, and take its remainder 12. That'd be 4. But notice it's a little awkward here because we have to change AM to PM. And the big problem is that in some sense, if we end up with 12 and we take the remainder 12, we get 0. But on this clock, kind of 0 is 12. So the 12-hour clock's not a great clock for kind of doing hour arithmetic. So there's another clock, and it's preferred by the military. This is one of the reasons why. It's called the 24-hour clock. There's no AM and PM.
The starting hour is at 0, it's 0000, and it's 0100, 0200, all the way up to 2100, 2200, 2300. And so in this model, we can do clock arithmetic in a much cleaner way. So I have an example over here. That involves, let's see, for 2000. What do we want to do? We want to go ahead 8 hours. So let me draw that real quick. So I'm going to go here, and that would be, I guess, 0400. So we'd like to go forward 8 hours here, so we could do that. We could say plus 8 hours. And so what could we do? We could use modular arithmetic to do this, and this actually is much cleaner because we could take 20 plus 8, that's 28, and we take a remainder 24, that's 4. So we can really use modular arithmetic and remainders to actually do essentially computation of hours on the military clock very easily, the 24-hour clock. So let's go back and do that in CodeSculptor real quick. So let's pop back over here. So here we have the hour is 20. So we're at 2000, say it's military time. And we'd like to go through and actually figure out what the time will be after we finish an 8-hour shift. So we could do that. We could say print hour plus shift remainder 24. So if we print that, we got 28 out. What happened here? We thought we were going to get 4. Well, let's think about this as in terms of precedence. Remainder has higher precedence than plus. So what happened here in Python was that we computed shift remainder 24. So let's see, the shift was 8, so it was 8, remainder 24 is 8. We added that to 20, we got 28. So to actually do this computation correctly, what we need to do is we need to go through and add first and then take remainder second. So we do that. What comes out is 4. Okay, let's do another example.
Okay, let's look at one more application using modular arithmetic. And this will be something that you'll actually do fairly often in the class. You're going to have a 2D game, objects are going to be moving around, and you have to deal with what happens when an object gets near the edge of the canvas. Maybe it's going to bang off of it, maybe it's going to come to stop, but sometimes you'd like it to actually do maybe something where it wraps around, it goes off one side and comes on the other side. Let me just show you a quick little demo. Here's a part of a game you're going to actually build later on. This is a spaceship, and our spaceship starts flying, and we get close to the edge of the screen, and what's going to happen? Well, it pops on the other side of the screen. It wrapped around. If I go off the top of the screen, I wrapped around. If I go back on the bottom of the screen, I appear on the top. So how do we model this mathematically? We could store kind of some information to represent the position of the center of the ship. But when we go off one edge of the screen, we've got to change that position so that it's kind of in a different position way on the other side of the screen. So we can use modular arithmetic to do that. So let's go back and look at this. So let's see we're in a situation that we've keeping track of the horizontal position of the ship. And so the frame that I created was 800 pixels wide. And so we're getting close to that right-hand edge. And we say we need to go right 5 pixels. How could we do that? Well, I claim we can do that using remainders. We could say position is equal to, well, the old position plus whatever the move was. We could do that remainder the width of the screen. And if we print out position, what's going to come out is 2. The position of the ship after we move 5 units right is not over past the right-hand side of the screen. It's actually over on the left-hand screen, side of the screen at position 2. So we've popped from the right-hand side to the left-hand side. The interesting thing, this also works the other way. And to do that, you have to understand how a remainder works on negative numbers. If we take the remainder of something that's negative, what happens is we're always going to get a number back in the range from 0 to width. 0 to the number that we're taking the remainder with respect to. So what's going to happen is when we take the remainder of something that's negative, we're always going to get something that appears on the screen, something in the right range. Let me just do that tangibly. Let's say we were the other way. Let's say we were at position 2. So we're going to kind of reverse this. We were at position 2, and we did a move of -5. We kind of moved to the left. We're on the left-hand side of the screen, and we move left. That's going to be -5. Run the same code. Well, what's going to come out? We're going to get 2 minus 5 is -3. So we have to find -3 remainder 800. And I told you that's always going to be a number between the 0 and the width. So it comes out at 797. So we kind of took -3, we added 800 to it. It gives a number between 0 and 800. It's 797. So we popped to the right-hand side of the screen. So notice using remainders here actually works in both directions. It works when you're moving left, it works when you're moving right, it works when you're going up, it works when you're going down. So remainder is going to be your friend when you're doing screen wrapping in your games. The next topic that I'd like to cover is talk a little bit more about how to convert back and forth between data types. In the lecture on arithmetic expressions, we talked about the operator int and the operator float, and how those kind of converted data in other forms into either an integer or a floating point number. There's times when you're going to have a number and you're going to want to convert it into a string so you can print it out. Your first 3 projects are going to involve really just doing lots of printing. You won't get into using the canvas and doing drawing until week 4. So what I want to do here is just talk a little bit about how you can convert things into a string. And so I'm going to motivate it by just talking about a very simple problem. So we talked earlier about the 24-hour clock. And in the 24-hour clock, you always kind of think about the hours as being 2-digit. Even if there's a 0 in front of it, even if it's like 3 a.m., it's really 03. So here, if 3 a.m. would be 0300. So what I'd like to do is talk about how to take an hour in the 24-hour clock and convert it into a string that looks like this, especially make sure it has a leading 0. So to do that, we're going to use a little bit of modular arithmetic, use some remainders. We're going to use what we talked about before we got the 1s and 10s digit. And then we're going to have to figure out how to do a couple of string operations to get those numbers and convert them into a string. And then we're going to have to figure out how to kind of format that string so it'll look like something in this form here. So let's see if we can do that. So the first thing is let's get the 1s digit. I think we've already done that. And the 10s digit. So we could just print those out. We could print 10s and 1s. So let's see what that looks like. Does that look good? Well, I guess we had a 0 and a 3. Okay, yeah, let's do this. Let's print out one more thing. Let's print out a string which has the minutes. We'll always assume the minutes we're even hour. So if we do that, we can kind of 03:00, and you can see there's a bunch of spaces in there, and it doesn't look very good. So what could we do here? We could try to convert these numbers into strings. That might be the first thing. And then we could think about if there's ways to kind of munge the string together to get something that looks like what we want. So, turns out that there's a function that we can do that. We can convert a number into a string using the str function. So we can try our next attempt. We could say print str of 10s. And str of 1s. And then we could keep printing out our string, 0, 0. So now, if we do that, well, dang, it's the exact same thing. This is now a string. This is now a string, but it just turns out they're exactly the same. But now that they're strings, we can do some things to them that we couldn't do with numbers. So for numbers, when we use the plus separator on them, we added the numbers. Turns out Python likes to take common operators and try to interpret them as being applied to things that you're not used to. So for example, there's a plus operator for strings. So what would plus operator do for strings? Well, it joins the strings together. So what I'm going to do is I'm going to try one more attempt here. I'm going to say print plus the string of 1s plus, and let's add in our little, let's try that, see if anything good happens. So notice what happened here now. This plus operator joined the strings together, and it didn't throw an error because this is a string and this is a string and this is a string, so it's nice to actually take strings and join them together. And most importantly, it didn't put in all these annoying blank spaces in here. This is an example that's called string formatting. And you're going to get good at it after the next couple of weeks here. But the most important thing is remember this function str. It converts something into a string. Just like int converted something into an integer and float converted something into a floating point number, str converts something into a string. Okay, let's finish off and we'll do one more thing. I mentioned that there are lots of other functions available inside Python. The way you get at those functions, these extra functions are built in things called modules. And they're kind of things that are outside basic Python that people have built and added into Python. And to get access to those functions, you need to go through and import them. So in Python, you need to say import module name. So if you go to the Hello World page, you'll see something that says import Simple GUI. Simple GUI is a module that Scott and I built that actually opens up a canvas and draws Hello World on it. There are two common modules that you should know about that you'll need to use as the class goes on. One is math, the other one is random. And you can take a peek at them up here in the docs. So we can go to Code Sculptor Python and scroll down. And there you go. There's the math module. We'll go scroll down there and see. It has kind of all the common math functions that you're used to. If you're looking for a math function that's not built into Python, you can say import math and go down here and use all these. If we go back here, for example, I could say print math.py, and this will print out a very nice approximation to pi. And the other one, then you're going to use them this week. It's going to be a random module, and it gives you the ability to generate random numbers. So it's also described up here. So let's go up and close that and go back down, and we'll look in the random module, and it's got a smaller set of functions here, but there's some functions that you're going to be using fairly often. The two that you'll probably use the most will be, it's going to be random.randrange. And so that one you should take a look at and figure out how it works, and you'll be all good. Okay, so those are some other functions you can use in this week and upcoming weeks. See you next lecture.